Hello and welcome. No, this is not a medieval oubliette. It also isn't a cell in the ADX Florence Supermax prison. We are in my home office and temporary laboratory. Today we are going to discuss dim bulb testers, and then we are going to build the deluxe version, and one of my viewers is going to get it for free. So, what is a dim bulb tester used for? It is used to limit the current going into a device that you are working on. Light bulbs are wired in series with the power outlet into which you plug your device. Therefore, you can't get more power into the device than can pass through the bulbs. In my version, I have a whopping 5 bulbs. Each of them is 40 watts. You can have anywhere from 1 through 5 of the bulbs in circuit, and you can also change the number of bulbs in circuit to increase or decrease the current getting through. Or you can choose to bypass all of the bulbs and feed your device directly. Finally, this dim bulb tester contains a fairly sophisticated digital meter that shows volts, amps, watts, and a couple of other things. So let's take a quick tour of the dim bulb tester, and then we will look at its design, and then we will build the giveaway unit. And here we have the dim bulb tester. This is actually my second prototype unit that I built. The first one was roughly identical, the only difference being that instead of using a small meter that ended up not having enough resolution when it came to current measurement, I put in this slightly larger meter, which we will demonstrate in a little bit. Starting from the left, this tester has a standard C14 outlet into which we have a standard PC desktop power cord plugged in. There's a 5 amp 20 millimeter fuse installed here, and as you can see, we have 6 backlit switches here, 5 controlling the bulbs, 1 for bypass. Here we have a power into the unit, here we have power out of the unit, and finally we have an AC outlet. So what we're going to do now is we're going to do an experiment. I have here a piece of wire, a 12 gauge wire with the end stripped off. I'm going to shove this in the outlet to make a hard short circuit. Just like this. Now let's just push that sucker in like that. And let's just say we're going to run 2 light bulbs with it. Let's turn the power on to the unit. You'll see they're lit up so you know what's going to fire off. And now, what do you think's going to happen? Well, here goes nothing. The short circuit was completely absorbed by the front 2 light bulbs. Those light bulbs are giving no more than 2/3 of an amp out. This wire can definitely handle that without getting hot. If that were your unit, you'd be protecting it by limiting the amount of current you could get in there. That would be 1/3 of an amp. I'm not going to trip the bypass switch because that will blow the fuse. But let's turn this off. That's basically how it protects. Now let's show it working with a piece of real equipment. What I have here is a cheap little Chinese hot glue gun. A hot snot shooter, 20 watts. Got it on AliExpress for like $3. We're going to plug that in. We'll fire up the unit. We'll put in 1 bulb. And immediately we see that it is giving some current, but we're going to zoom in so that you can read what's actually going on. And now, with 1 bulb lit, you can see 52 volts are getting through, 0.24 amps, 12.7 watts. It's going up slowly, as you can see. That happens because the load is resistive, and as a resistor gets hot, it changes, usually decreasing in resistance. What we're going to do now is add a second bulb, and you're going to see the voltage jump up. It's going to jump all the way up to practically the whole shoot and match because of the small size of what we have connected. If we were to go through and hit the bypass, The bulbs are not in this at all now. Now it's a straight connection. The full power of the line is going through to the unit. What this allows you to do is to slowly bring up both voltage and current, especially when you have a variac in the line to control the voltage. You can bring it up and you can protect your unit from damage. This is extremely important when you are dealing with older equipment where you have very old capacitors, some dating back to when Richard Nixon was president, and when you have the potential of destroying the electronics. By limiting the amount of current, you can detect a problem before it becomes destructive to the piece you're working on. So that's the basics of how the dim bulb tester works. Now I'll show you a schematic diagram that explains the circuitry that's involved. Then we're going to go ahead and build it. And here we have the schematic diagram for the dim bulb tester. To safely test outlet-powered equipment, the wall power is generally connected to an isolation transformer and that transformer to a variac in order to give you maximum safety and control when you are powering up the gear you're working on, especially for the first time. Then the dim bulb tester is connected to the variac, and finally the item you are testing is connected to the dim bulb tester. You then have a ground-isolated, variable voltage, current-controlled power source. Now let's look at how the dim bulb tester works. We start off with a standard C14 power socket into which a standard power cord connects. Next, on the live side, you have a 5 amp breaker or fuse. If you decide to use a fuse, please use a slow blow fuse. After that, we have the initial power switch, a double pulled switch which pulls the power into the unit. After the power switch, we have 5 light bulbs connected to the live side in parallel, each with a backlit switch. That allows you to choose up to 200 watts of power to be allowed through without any limitation. The more bulbs you activate, the more power can get through to the item being tested. Each 40 watt bulb will allow 1/3 of an ampere to come through to the tested gear. Therefore, if all 5 bulbs are enabled, you can allow up to 1 2/3 amps to come through to your equipment. You might be wondering why we have a 5 amp fuse or breaker if the limit is actually 1 2/3 amps. That's actually not the limit because we have this, the bypass switch. If this switch is enabled, all the bulbs are bypassed regardless of what you have set with the other switches. Why? Because this bridges the gap and the electricity will take the path of least resistance. You'll be directly connected to the power. Therefore, with the bypass switch set, you can let up to 5 amps into your equipment before you trip the breaker or fuse in the dim bulb tester. After you have configured the dim bulb tester to limit current the way you want, you can hit the enable switch. That will send the current flowing through to whatever is plugged into the load. You'll notice here that I've inserted both a voltmeter and an ammeter into the circuit in order to measure voltage and current. I use an integrated electronic meter that measures voltage and current simultaneously and reports it out onto a screen. That's my preference. If you decide to build one yourself, you can choose to put in old-fashioned analog meters, individual digital meters, or whatever else makes you happy. At the end of the line, we have a standard AC power outlet. That's what you plug your gear into. So the device is quite simple. Once you understand what's going on in the design, you can do some tweaking if you desire. So let's get into it and start putting it together. And here we have the pile of parts that we are going to turn into the dim bulb tester. Let's go through them real quick, shall we? First, we have an empty box. This is an electrical box made out of ABS. It's designed for outdoor use. I've already cut in and labeled out a hole for the input connector, the C14 connector. Next we have the front cover for this, and as you can see, there are some very badly cut holes in there. This was my first prototype. I thought I had chops using a Dremel tool to cut perfect rectangles. Turns out, not so much. So I did something a little different. What I did was this. That is actually a printed circuit board that I bought from JLC PCB. I did not tell them that this was for a video. I paid normal price for it, and they have no idea that my channel even exists yet. What I did is I measured out the holes for each of the bulb switches, as well as the bypass switch, the power switch, the meter, the circuit breaker, which I'll tell you about in a minute, and the power outlet that comes out the bottom. My plan now is to mark out roughly 10 to 15 millimeters going inwards from the edge, cut out a large square in that panel, and then we're going to attach this with these nifty little black screws right here with nuts on the back end. And that'll give us a nice clean look out the front of the unit. Next up, we have 5 ceramic bulb sockets. These are going to be screwed into drilled holes in the top, and the wires will be routed through larger drilled holes at the top, into which we're going to insert some rubber grommets just to make it look good. They're not necessary electrically or any other reason. There's no water going to be used near them. We then have the outlet, which is going to go into the side, sort of like that. This one's going to pop in here. And then we have the meter. The meter is going to be connected to both the live and the neutral side of the circuit. In fact, the meter has a little bit of a schematic diagram on the back to show you how everything connects up. In addition to measuring voltage through the line directly, there's going to be this sensor which clamps around the wire. You can open it like this, snap it on the wire. We're going to do that to the live wire going out toward the outlet, and we're going to route a little bit of extra wire, and then we're going to hot glue this to the back of the unit. Or perhaps it might be better, now that we're talking about it, to hot glue it right about here. Next up, we have a bunch of switches. These are the bulb and bypass switches. We need 6 of them. Now, if you'll notice, they have 3 connectors on each one. 1 gold, 2 not gold. The 2 not gold are the circuit, which is going to be connected to live. The not gold, they're all going to be connected to each other and to the neutral side of the circuit. That means that when you hit the switch to turn it on, it will light up when power is in the unit through the power in switch. And again, all we have to do is push them in and they will snap in cleanly. In addition, we have some crimping lugs which we're going to use to connect all these. Soldering all this is just not the way to go. We have some heat shrink, and then finally, reaching around the camera here, we have a 5 amp circuit breaker instead of a fuse container. I figured since I'm building this for you guys, I might as well build one that gives you a little bit extra panache. So we're just going to screw that onto there, and if something happens, the breaker pops, and instead of having to hunt around for a fuse, you can simply reset the breaker after turning off the power, hopefully, and get it done. Finally, we have a bunch of 14 gauge wires, stranded, silicone jacketed, so it's good stuff. And we're going to use that for routing all the wires inside the box. Other than that, miscellaneous electrical tape. You'll also see some wire nuts, and you'll see us use the shrink wrap tubing. Most people would seal that shrink wrap tubing with hot air. I'm tempted to use my torch, but we'll see how it goes. So that's the parts list. Now it's time to start building. The first thing we're going to have to do is mark off and cut for putting the face plate on here. After the face plate hole is cut, then we'll set it, mark the holes, drill them out, and attach it. What we have here right now is the front plate made out of the PCB placed on top of the door. What I'm going to do is I'm going to center it as carefully as I can and check it from all four sides. Seems to need to go a little to the left. Okay, there. Now we're going to mark off the edges using a pencil. And now let's take a quick look at the marks. They're pretty much square and ready to go. So now with that done, I'm going to take a ruler and mark off 15 millimeters inside from each edge at a couple of points so I could draw straight lines. And here we go. I used an oscillating tool to cut out a large rectangular hole in the front cover. And then I used a drill to put 8 holes along the edge that match up with the holes that are in the printed circuit board. So what I'm going to do is take some machine screws that are M3, 10 millimeters long, run them through, bolt them on, and then we're going to go ahead and proceed with assembling the tester in earnest. So let's get started. As you see, we're going to put some screws in like this. And then we're going to begin attaching them by putting little M3 compatible nuts on the back. And we'll tighten them all down and we'll be ready to go. But a lot easier to do when you can switch hands. John Tinker's Trivia, I'm a 99.2% ambidextrous. There we go. Now, let me go to my magical drawer of tools and pull out a socket driver that will fit this, and I believe this is the one. One off. And then I've got a hex driver for the other side. Let's just tighten this down. Okay, this is on, and it's secure, and it looks good. Next up, we'll be putting everything together. Okay, I've gone ahead and installed all of the switches, the meter, and the outlet into the front panel. And that's what it looks like from the back. Let me get it here fully into screen view for you. And we're going to begin connecting wires here shortly. First, however, I need to do a little bit more drilling into the box itself in order to attach the bulb fixtures there. That I will do, and then I'll be back. Okay, we're ready to take a look at what we need to do now in order to complete this assembly. First of all, we have the C14 jack installed, screwed into place. Helps if I focus. And I've even attached the ground wire. As many wires as possible are going to be attached with spade lugs because they're used a lot in both the switches and in everything else. Next up, we're going to put the light sockets in. Each light socket comes with 2 wires, and those 2 wires are just open twist ends. We're going to lengthen all of them, but we're going to common up one set because they're going to be parallel going out into the power, and then on the inside we have to come from the switches. So let's get busy. And now we have the bulbs installed onto the box and we're ready to start wiring. And now it is wiring time. First thing we're going to do is we're going to take the black lines from all of the bulbs and we're going to bring them together. Let's get a wire nut and let's cut ourselves a length of black hot cable to keep track of this all. So let's get the cable first since it's right here. And I figure that about 30 centimeters. Yes, I am using metric even though I'm in America. Just twist this up and I've got to go get a wire nut. You'll see a quick cut. Here's a nice little wire nut, perfect size for what we're doing here. There we go, nice and secure with a wire nut. Now let's tape it off, just for safety. So now we have a connection that can go on. And this one's actually going to go into the switch along with the bypass output. Next up, we need to put little ends on each one of these to go into the individual bulb switches. This is going to be number 1. Oh, should I go bat cave on this? Yeah, maybe I should. It's bat cave time. There's number 1. Let's get out a little bit of wire here. And put this on here. We will twist. If we can get it twisted like that. Let's untwist this one here. And then after I do this one, I will go to speedy mode to make it a little less boring. But first, we need to shrink the tube. Now my torch will work. I refueled it a little bit. Okay. I've made a few more connections here and now I'm going to start grouping these wires together. I have a white jumper here to remind me that we're dealing with a neutral. We're going to twist these together, wire net them, and then tape them for security. So they're twisted and I'm going to need a large wire nut. And I'm going to get one of those right now. One moment. Nice big honkin' wire nut. It's nice to have stuff left over from when you did your basement wiring for your electrical. And the fact that we are not on fire shows that I followed code. Hopefully things stay together for this. Now we need to bundle up these connections here like this, and we will have need for one more wire, because this brings all the neutrals together, but we still have to bring it out of the device. And that will go, it'll be a jumper from here to here, which is the neutral on the outside. But we do need a jumper from here to there. And we're going to connect the ground to the output ground since that's a straight through connection and we don't want to forget it. Okay. Next up is to bridge all the rest of these wires together from the bypass and the bulbs. And then we can go on to wiring out through the meter and we can call this thing done. We'll test it and providing we survive the test, we will be ready to go. Okay, as things are starting to get wound up here, we're going to go ahead and put the line side into the meter. Okay, sensor opens up like this. We're going to snap it over the wire like that. We're going to connect these two leads into the meter here and here, and then we're going to hot snot this onto the back of the PCB to keep it secure. And while we're doing that, we have one last connection to make. That is from the neutral switch for output to the neutral of the power outlet. Okay, that side's connected. One more connection and we're going to be ready to test it and see whether or not we survive. Oh, one other thing we have to do first. I just noticed we have no light bulbs in this dim bulb tester. We will need to add those, of course. And now it's time to goop in the current sensor. Got a nice big booger of hot snot. And it is attached. That, my friends, is a completed dim bulb tester. Power comes in here. The live and the neutral go through a double pole switch and get fed through the light bulbs that are turned on through these 5 switches, or get bypassed if the bypass switch is set. Then the current goes through here, this second switch, out there through the meter to give readings, and then out to the outlet. It's actually pretty simple once you think about it. So we're going to close this up. And our next step will be to put on some light bulbs. Bulb time! So, I'm going to back out just a little bit here. You must use incandescent bulbs. That's one reason I did it with 540s, is because you can get oven light bulbs still to this day without any real hassles. They're available readily on Amazon. Let's tilt this up a little bit. And 5. You cannot use LED bulbs because they offer no resistance. LED bulbs are more or less a closed circuit, very close to a short circuit. If you think about it, a diode is something that allows current through in only one direction, but it allows all the current through minus the negligible voltage drop, a small epsilon for that. Okay, next up, we're going to test our little invention here and make sure it all works. And if it does, we're going to be ready to call this video done, and I can hardly wait, as I'm sure you can either. I don't want this to be boring for you guys. Here we go, the dim bulb tester is done. All the bulbs are in, we are plugged up to power, and I just made myself a new one of those little shorting thingies. A little piece of 12 gauge wire which we are going to shove into the power socket. We'll turn it on. We'll set 2 bulbs as we did before. Here goes nothing. Ooh. And we have something connected wrong, because that should not happen. And I bet I know what it is. Okay, I tinkered for a while to figure out what was going on. I figured it out and everything works. Let me put the short circuit wire in here. We will set bulbs 1 and 2, power on to the unit, power on, and you see the bulbs pop immediately up. And doesn't matter how many I add or how many I take away, it catches the short circuit. Now let's replug the hot snot shooter and see what that does for us. Plug it in, turn it on. Let's put 1 bulb in, and you see we get a tiny glow. If I add 2, we're going to get 2 with a very tiny glow. Would help if I backed out just a little bit so you could see the glow fades out. But if we go back, you'll see that it glows a little bit. If we go in to read the voltages when we hit bypass, you'll see that we get the entire line voltage, and we get wattage of about 15 to 17 as the resistive load starts to come up. So this all works. We have a done project. Now for the big news. Somebody is going to get this free of charge, sent to them by me. All you have to do is comment on this video with something that says hello from and your country. If it's not in English, that's not a problem. We can't ship to countries that the US won't let us ship to. This has a value of about $325 US. We won't cover tariffs, we won't cover taxes, we won't cover VAT. But someone gets it for free. When will we do the draw? As soon as we hit 5,000 subscribers. However, subscribing is not part of the deal. You do not have to subscribe in order to put in a comment and enter. This contest is not sponsored by, sanctioned by, or otherwise approved by YouTube. We are doing our best to make sure that we meet all guidelines that YouTube puts out for giveaways. So, thank you for watching. We really appreciate it. Please hit like or subscribe. Our next video comes out in about 2 weeks, and we'll be having fun with oscilloscopes. Have a great day. May you have joy unspeakable and full of glory, and the peace that passes all understanding.